Okay. So I've started recording it and I hope everybody can hear me okay. Yeah.
Yes, sir.
Wonderful. So what is that we are going to do today? There are two things primarily, and that is based on the feedback I've received from some of you, uh, asking for kind of reiterating that. So one is standard deviation. Okay. Standard deviation. And second one is about the different forms of linear equation. We'll probably touch upon the slope intercept form, and if time permits, we'll talk about the standard form for the linear equation as well. Is that okay? Or you guys have something else also in your mind? I would assume silence to be a yes. So let's get going. Everybody can hear me okay? Everybody can see the screen okay?
Yeah.
Yeah.
Okay. So first of all, what is standard deviation? I think we have talked about that in the past, but let me try simplifying it, because every time you ask me to teach you guys something, regardless of whether we have gone through that or not, I'll make sure that it's not a repeat telecast. It's something different, something new, something creative. So when you say standard deviation, what exactly does it mean? This, let's say this is my speed. All of a sudden I press the gas pedal, I start going very fast. Then again I slow down. Again I press gas pedal, and then I'm still going at the same speed. Then I decelerated, start going very slow. Again the again caught up. Then okay. So I'm just doing some random drawing here, right? What I'm trying to show is, this was, let's say this was my speed. Let's say this was 50 miles per hour. Okay. Then all of a sudden I pressed the gas pedal. I went to 90 or 85. Drove at that speed, and then I realized, oh, I'm going way too fast. Slow down. Come back to the speed 50. Again, I sped up, and then after some time, I slowed down. And then I realized that, okay, I'm probably getting closer to my house. Slow down further. And I decelerated big time. So from 50, I came down to 25. Again, increased a little bit, went to 35. Okay. Again, decelerated further. So here you're going up, and here you're going down. Okay. Now, again, decelerated further, went to maybe 30. Then came back to 35 and reached home. Now, here in this whole journey, that stupid thing that I've drawn on the screen, what do you see? Standard speed. This might, let's say this was my standard speed, or speed of traffic. This is the same speed. Went up, came down. Went up, came down. Came again, went even negative. I mean, below 55 or 50, whatever my standard speed, I went down. You see all the deviations. These are the deviations. If this was my standard speed, all these are deviations. These are deviation. This is negative deviation. This is negative deviation. How much of deviation? Look at the two scenarios. Somebody going like this, or somebody going like this. I mean, this flat line shows the speed. Let's say this is 50 miles per hour. This flat 50 line. Here 60 became 60, came down to 50, became 65, something like that. And then you look at scenario like this. What you're seeing here is, this one is, there's not much deviation. This has little deviation. This has too much of deviation. Okay. Everybody with me so far, conceptually?
Yeah.
So
Yes,
this is
sir.
no deviation, little deviation, too much of deviation in the speed. And standard deviation gives us that way to find out mathematically. Find how much is that deviation mathematically. Okay. That is what we're going to talk about. So, in summary, standard deviation is a technique or a tool used for finding out what is the general trend of the data set that we're dealing with? Is there a lot of deviation among the numbers, or is it staying flat with or closer to the average? Let's look at one more example, and then we'll come to the formula of this. Let's say we're talking about score. Let's say we're talking about a class test where we had 30 students, and this class test was for 50 marks. Okay, and some people got 45, somebody got 43, somebody got 30, somebody got 15, not prepared, right? Somebody got a zero also. Somebody got 49. Some intelligent kids like you got 50 also. Yeah. Now here, I mean, again, this is a data or the marks obtained by 50, 30 students in the kid out of 50 in the class test. And what you're seeing here is, look at this number, look at this number, look at this number, and look at this number. There's so much of variance. It's ranging literally from one end to other end. So if we can find out how much is the standard deviation, then we will know that okay, if the class's average is staying in control or there's so much of fluctuation in that, and that is what we'll get by standard deviation. Okay. So before I continue, any questions so far? Any doubt? So we are talking about standard deviation. So far, our takeaways in one line, we are saying that standard deviation is a means to understand how much of a deviation I'm dealing with in my data. Yeah. If everything is as simple as the average, if everything is, let's say, everybody got either 42, 41, let's say we're talking about 5 students in an exam with 50 marks, people got something like this. All are pretty close. There's not much of deviation. Imagine the same thing with a different scenario where 5 students got, one got 15, one got 19, one got 49, other one got 12, and another person got 47. See here, there's not much of a deviation. This is pretty much flat on a similar line. You have too much of deviation here. And that's where standard deviation gives us a mathematical way to find out. Higher the value of standard deviation, more turbulence inside the data set that we are looking at. Smaller the standard deviation, less turbulence in the data that we are looking at. Yeah. Are you guys with me?
Yeah.
Okay. Everybody, right? I don't want to hear a yes from one person and then I generalize that say, okay, everybody's okay.
Yeah.
Everybody's fine. Yeah.
Yes.
Okay.
Yes, sir.
Okay. Good. Now let's look at some example and then we'll try to look at how the formula gets derived from that. Let's say I have data for 5 kids. Okay. 5 kids as in, let's say there was a science test and that test was for 30 marks, let's say. Okay. One child got 28, another person got 15, third person got, let's say, 26, fourth person got 29, another person got 18. Okay. This is the marks scored by 5 students in a class test, which was for 30 marks. What we are trying to do is find out standard deviation, meaning is there so much of variance in the score or not in a mathematical way. First thing, what is my smallest number here? 15. What is my largest number here? 29. Yeah. What is the difference between the largest and the smallest number in this group of number? 29 minus 15. Correct. This is the range that we are looking at. So basically, the marks obtained by 5 kids in that exam is ranging from 15 to 29. Yeah. Do you guys agree?
Yeah.
So I'm just repeating myself. So there was a test for science, and five students got marks like this. In a test of 30 marks, one child got 28, another got 15, third child got 26, then another one got 29, and one got 18. Now, what is the smallest score or the least score by any child in that group? 15. What is the maximum? 29. What is the range? It is basically range is nothing but the difference between the highest and the smallest number. Or we can say the kids got score in the range of 15 to 29. Yeah. And this is essentially what it is. Oh, sorry. Let me go to next 28, 28, 15, 26, 29, 18. I just need to have these numbers with me. So what I said was the kids score marks in the range of 15 to 29. 15 to 29, because these were the smallest and the largest number. This is exactly what we do in math also. As I keep claiming, right? Math is nothing but English. This is how you find the range. If you are given a set of numbers, if you, and you are told to find out the range would be the largest number minus the smallest number, or the biggest minus the least value in the range, or the set of numbers that you have. Okay, this is the first thing. Now, are we clear so far? What is the range? This is simple thing, right? We have not started learning maths yet. This is English. Yeah, everybody with
Yes,
me?
sir.
Yeah.
Yes, sir.
Okay.
Yes,
Now,
sir.
next thing is, okay, I'm just hearing Shivatsav's voice. Shivatsav, have you joined? No? Okay, he missed. All right. So we see, okay. So this is my range. This is the first thing that we need to do. Next, we need to know what is a variance. So variance would be, before we do that, do you guys know what is the mean for these five? I mean, how do you calculate the mean of any set of numbers? This is just the average, right? Sum it up, divide by number of numbers. Correct? Here my mean would be basically the average of all these. So let's add it all. 8, 9, 17 plus 6, 23, 28, 36, 6, 5, 6, 8, 10, 11. Yeah. And divide that by 5. This is what my mean is. So 5 to the 10, uh, 1, 5 to the 15.2. This is my mean. So for no issues, we found the range. I mean, the highest minus the smallest in the range, and we found the mean. Now next thing comes is called variance. Variance is, this is where the mathematical formula comes into play. Variance is nothing but mean minus, okay, or you can say this, data minus mean square sum of all these, okay, by the number of numbers. So here variance is nothing but, now this might be looking cryptic, so but don't worry about it. We just found the mean, and this mean is to be subtracted from each of these numbers. Okay, so every date number minus the mean and find out the square of that and sum it up, divided by how many numbers we have here. So we have total 5, so we'll divide by 5. So first thing you have to do is find out how much is each number different from the average? If you look at this, right, when I was drawing this picture, what I meant was I was saying that when you have more deviation, meaning deviation from the average, that is what is the standard deviation, right? So here, just relate to that. Every number that you have, how different is that number from the mean? And take a square of that and find out the average. Basically, every difference that you see against the base or the range or the mean, take a square of that, divide that by no, by the number of numbers you have, and then we'll see next. Okay, so let's go back to the this one. So here, let me do some cleanup. So my range I don't need right now. What I need is the mean, and my mean was 23.2. If you guys remember, yeah, I'm just noting it down. My mean is equal to 23.2. That is what we found out. So what we'll do here is, I was saying, first we'll try finding out the variance, meaning how every number is different from the mean. So let's look at the first one. First number you took, 28 minus 23.2, square of that. I said sum of all the differences square. So first number and the mean difference of that. Second number minus the mean, 23.2, square of that. Likewise, you will add all these. So 26 minus 23.2, square of that, plus 29 minus 23.2, square of that. Okay. Find out the square of, and then the 18 minus 23.2. All that you do is take out the mean and subtract the mean from each number that you have here. Okay. And find the square of first number minus mean square, second number minus mean square, third number minus mean square, fourth number minus mean square, and you add all the squares together and then divide that by the number of numbers you're dealing with. If you have five numbers, divide that by five. Is this part clear? I know I'm scribbling on the screen with my finger. That's why it's looking little messy, but I hope you guys can understand what I'm trying to say here. Yes or no?
Yes.
Okay, okay. So let's do it for simple sum. So that way it'll let's, so whatever I have said, let's try finding out the range and the variance. Let's look at three numbers. Let's say 15, 12, and 18. Let's say. Okay. Now, first of all, what is the mean or the average? This plus this, 45 by 3. My mean is 15. Okay. So I got my mean as 15. Now what I'm saying is, to find out the variance, what you have to do is variance. What I said was, take out the first number, 15, minus the mean. Mean is 15. Okay, square of that. Plus the second number, 12. 12 minus mean, which is 15. Take square of that. Plus third number is 18. 18 minus the mean, 15, square of that. You have to sum it all and then divide by what? Divide that by the number of numbers I have. Yeah, it'll be 3. Yeah. See, I'll keep waking you guys up, okay? Because I make the kids sleep sometimes. Yeah. So I'll keep waking you guys up by asking questions in between. Okay. Just be with me. Now, so I have 1 as 15 minus 15 square plus 12 minus 15 square plus 18 minus 15 square. divided by 3. That is, if I find that out, that'll be my variance. Are you guys with me so far?
Yeah.
This is
Yes.
what? 0. 0 square is 0. 12 minus 15 minus 3. Square of minus 3 is minus 3 into minus 3. Minus minus plus 3 into 3, 9. Okay. And 18 minus 15. This is 3. Square of 3 is what? 9. So in total, I got 0 plus 9 plus 9 divided by 3. So 0 plus 9 is 9 plus 9 is 18 by 3. So I got my variance equals, how much did I get?
6.
6. My variance equals to 0 plus 9 plus 9 divided by 3. And 3, this 3 is nothing but the number of numbers I have in the set for which I'm trying to find out the standard deviation. Yeah. So this got me 6. Now, standard deviation. There is no formula. Standard deviation is nothing but standard deviation is nothing but square or square root of variance. Okay. What did we get as a variance? It was 6. Square root of 6. That's what my answer is. Okay. So now let's do a recap of what we have done so far. Okay. First thing is, let's say, first thing we understood was standard deviation is nothing but a mathematical way to find out how much is the fluctuation in the data that I'm dealing with. Am I looking at a flat data or I'm looking at data varying too much? Let's say if you try relating that with the score obtained by kids in the class or height of the kids in the same class, right? Or whatever be the data. If you are seeing too much of fluctuation, let's say if the kids are of varying heights in the class, you will see that the average, no, sorry, standard deviation is going to be more. If all the kids are almost the same height, you will see standard deviation being less. And that is exactly what it is. Standard deviation is nothing but a reflection of how much is the variance that you are seeing in the data that you're dealing with. Am I making sense so far?
Yes.
Yeah.
Okay. Yeah. So that's a simple way. If somebody says standard deviation is very high, I don't know what to do. Simple interpretation in layman's term would be okay. That means you're talking about set of data where the values are varying too much against each other. If somebody says, okay, I have almost like flat data. I mean, everybody has almost the same score. Your interpretation would be, oh, that means standard deviation is very little. So what we have learned so far is, first thing is, if I have, let's say, data, 3 numbers A, B, C, or 5 numbers, let's say D and E also. My first thing I need to know is range. What is my smallest value and the largest value? Let's say B is the smallest and E is the largest. It'll be E minus B. So whichever is the largest minus the smallest, that is the range. That tells you what is the range of data that you're looking at. Or you'll say, okay, like we use that in common talking also, right? We say that, okay, yeah, my values are ranging from this to this. Or between the age of 5 to 8, my height has ranged from, let's say, 3.5 3 feet 5 inch to 4.8 inches. Yeah. 4 feet 8 inches. So range is nothing but that thing. And then comes the variance. So variance is nothing but, I'm just writing the formula, it is sum of number, each number minus the mean. Sum of square of this, every number minus the mean square of that, divided by number of numbers. If I have 5 numbers, I'll put 5. And once you find out the variance, standard deviation, it is nothing but the square root of variance. Okay. So this is all about standard deviation. That's what we have learned so far. Um, any questions before I do my own validation to see if everybody has understood or if I have explained things in an easier way for you guys.
Yes, everything. I got everything.
Okay. How about you, Praneeth, Rutvik, Atharv, Isha, Vaibhav? Everybody, everybody understood?
Yes, sir.
Okay, that's good. That's really good. Okay, so let's do a bit of practice, okay? Because I'm not making you guys do practice because I want to test your skill or knowledge. I'm just trying to test my way of explaining things. So what I'll do is I'll give you two numbers, okay? Two set of numbers. One is 12, 14, and 22. Okay. This is one set. And second set is 16, 17, 18, and 19. Okay. Help me find out standard deviation for this number and this number. This set of numbers, find out the standard deviation. This is first question, okay? And this is my second question. Find out the standard deviation for this set also. And then I'll tell you why I gave you a question like this. Can you guys do that real quick? You guys have maybe maximum 5 plus 5, 10 minutes, not more than that, or even less. And once you guys are ready, you can raise your hand.
Can you go to the numbers, sir?
Yeah, sure. Yep. Who's ready? Yes, sir. Tell me what is the value for your first and second question.
The first one standard deviation
Mm-hmm.
is 18.6.
18.6.
Yeah.
Okay. And how about this one?
The second one is 0.765.
Okay. Okay. I will let one more one more of you finish, and then we will come back to resuming from there. Okay. All right. Is anybody ready? No. Yes. Oh,
No.
no. Okay. Um. Fine. I know in the exam you'll not get 5 minutes. You'll probably get a little more than that. But let's try solving it together. Okay. So here a third gave two answers. Okay, 18.6 and 0.76, and I'm just trying to find out or derive some interpretation from that. When Atharv says 18.6 is my standard deviation for the first one, my interpretation would be I'm not looking at the numbers. The way I would read this is okay, standard deviation is actually high. Anything above 2, 3, 4 is yeah, it certainly is not something that I can ignore. This is sizable number. Okay, standard deviation is high. Now, in what circumstances my standard deviation would be high? When my numbers are fluctuating quite a lot. So I have 12, and next one, the highest is 22. So basically, I'm dealing with a big range. My smallest is almost half of my highest. So yeah, this is possible. Okay, this is possible. I'm not agreeing to a third. I'm just relating. Okay, it looks to be correct. Let's see. Now the second one, when I see my standard deviation is 0.76. My smallest number is 16, biggest is 19, and then 16, 17, 18, 19. Yeah, numbers are pretty close, not very far. Unlike the first group where we had 100% difference. Here 16 to 19, 20% deviation. This could be right. Let's calculate, okay? Because as I keep telling you guys, don't trust me. Math is a subject to be done by yourself. Okay. So 12, 14, 22. 12, 14, 22. I'll try doing it a little faster. Okay. This is my number. So what is my mean? My mean is 36 plus 12, 48. 48 by 3, 16. Okay. Now, what is my variance? Variance. I'm just writing short form. First one is mm, number minus mean square. 12 minus 16 square. Second one is 14 minus mean square. Plus third one is 22 minus mean square. Okay. And then divide that by total number of numbers. So we have three numbers. I'll put it 3. So my variance is what? 12 minus 16 minus 4 square. Minus 4 square is 16. Plus 14 minus 16 is 2. Minus 2. Minus 2 square is 4. Plus 27 minus, sorry, 22 minus 16, 6. 6 square is 36. Divide by 3. How much that is? 16 plus 420 plus 36. 20 plus 36, 56. Divide by 3. Okay. Now, standard deviation is nothing but square root of this value. Okay. 56 by 3. So 56 by 3 is what? 56 by 3 will be somewhere around 18, 18 point something, 18.66 or something. So 18.66 square root of this. So third, you probably got the variance, not the standard deviation. Once you get the square root of this, it will be somewhere around 4 point something. Okay. So 18.6 that you got, that was nothing but the variance part of it, unless I have done something wrong here. So mean is 16, 12 minus 16 square, 14 minus 16 square, 12, 22 minus 16 square by 3. 12 minus 16, 4, 16 plus 4 plus 6, 36 plus 4, 40 plus 6, 56. Yeah, yeah, yeah. So you got variance, not the standard deviation. So once you take the square root of that, that will be your uh, standard deviation. So that is why I was saying I did not go to 18, right? I said that no, if your variance is anything above 2, 3, 4, 5 numbers like 4 or 5, that means that's a significant variance. Okay, good standard deviation. So here it is close to 4 point something. Okay, so that still is standard deviation. Any questions so far with respect to what I'm doing on the screen? Athar, do you agree to what I'm doing? What I said?
Yeah.
Yeah. Okay. Yeah. Now, same way, the next one. So here the standard deviation was somewhere around 4 point something. Okay. I'm not doing that thing. We can do that using calculator also. But 56 by 3, square root of 56 by 3, that's what my standard deviation is. Isha, Dhanushri, Praneeth, Ratvik, Vaibhav, everybody with me?
Yes.
Yes, sir.
Okay. Okay. All right. What was my second number? Let's second set of numbers. This was 16, 17, 18, 19. 16, 17, 18, 19. And what is the value that Atharv told is 0.76. And again, when I'm saying what Atharv told, I'm not trying to put Atharv on the spot. Okay. I'm just saying what is my reference point. Okay. 16, 17. If any of you make mistake, I'm perfectly fine with that. I actually love when you guys make mistakes. Okay. Because mistakes teach you the right thing. All right. So here, what is my average? What is my mean? Mean is 16 plus 17 is 33 plus 1851 plus 19. 51 plus 1970. Yeah. And by 4. It will be like 35 by 2 or 17.5. This is my mean. Now variance. Same thing. First number minus mean square. 16 minus 17.5. So 1.5 minus 1.5 square of that. I'm just doing it shortcut, okay? Second number minus mean square. 17 minus 17.5. That gives you minus 0.5 square plus minus 0.5 square. Third number 18 minus 17.5. So that is 0.5 square plus 19 minus 17.5 square. So 19 minus 17.5 is 1.5 square of that. Okay. So now look at this. This is 0.15 square, zero point 0.5 square, zero point 0.5 square. So, and then this divided by 4. This is going to be 2 into 1.5 square plus 2. I'm just doing my shortcut math, okay? 0.5 square by 4. So 2, okay. So I can take 2 out into 0.5 out. Okay. No, I'll not do that. 0.5 square. 3 square plus 1 by 4. 2 into 0.5 square. 1 into 0.5. 0.5. Yeah. What was the answer? Point, 0.5. Yeah. So here, maybe with whatever rough calculation I'm doing, I'm getting point. My variance is 0.5. Is that what you got, Thurf? Thurf? Did you get your variance as 0.5? Thurf, you're talking on mute. Okay, so any which way, um, I'm just trying to solve it quickly, just doing the calculation. But yeah, the approach remains the same. You find out the mean of all the numbers and then subtract the mean from each number individually, and whatever the difference, square of that. Second number minus mean square of that. Third number minus mean square of that. Fourth number minus mean square of that. And then just add those together and divide by the number of numbers. And then once you got that, that is your this is your variance. And then if you take the square root of that, that is what gives you the standard deviation. Now, if it is 0.5, square root of that will be square root of that will be somewhere 0.75, I think. So Atharv's number, Atharv's value looks okay to me, unless I am making mistake while doing the calculation or the rough calculation that I'm doing right now. I will let you guys do a few more calculation with the standard deviation, and that would help you practice. But so far, whatever we have learned, any doubt, any question about it? And be honest, okay? It's okay. If I have to repeat it, I don't mind. But it's not okay if you guys say yes and later on we realize that okay, we could have learned it better. Hmm? You guys are not afraid of me for sure, right? As a teacher?
Yeah.
Yeah, meaning you're afraid or you're not afraid?
Oh, we're not afraid.
Not afraid. You need not be afraid, okay? Because when you're afraid, you are compromising your chances to learn. Okay? Don't be afraid of teacher hours. So now, yeah, now whatever I have told so far, have you guys understood, or there's some doubt?
Yeah.
And
Sir, I have a question
Yes,
on
sir.
the last problem.
I'm
I got
sorry, Ritvik.
I on the last problem I got 1.25.
Okay. So you might be right. Okay, you might be right. I might be wrong because I was in a hurry to kind of focus more on how to do it. Answers will come with the practice. Okay, if I sit and do it now, we might have the same thing. But only thing that you have to remember is when I'm doing standard deviation, my first job is to get the mean of the numbers and then subtract that mean from each number one by one. Pick the first number minus the mean, then square of it. Plus, pick the second number minus mean, square of that. Third number minus mean, square of that. So you have all the numbers that you have. Find out the mean and subtract the mean from each number and keep adding the square. And then find out the average of all the squares. Meaning, if you had 5 numbers, divide the square that you found, the difference square of the difference that you found, divide that by 5. That is it. Yeah.
Okay, sir.
That gives you the variance, and then once you have the variance, then standard deviation nothing but the square root of that. So it's like first time you do find the difference and do the square, and once you found the square and found the average of the square, do the square root. So you are reversing it now. Okay, so that's the approach. And like you guys saw, um, the first one. Okay, I stopped sharing my screen, so let me share it again. So first one that you guys saw, this one, the number with too much of variance. Oh, sorry. So our first number was 12, 16, 22, right? So here the difference was too much. So that's why our standard deviation came somewhere around 4.4, 4.5. When we looked at this one, 16, 17, 18, and 19, right? Beat Athav's value as 0.76, or beat my value as a square root of zero point 0.5, or beat Rutvik's value of 1.25. In all the three scenarios, this number versus this number, you see here the range is bigger. Your standard deviation will be more. Here, everything is pretty close to each other. That's why your standard deviation will be less. Okay. So you can clearly see the difference. So that is what the interpretation is. The mistake that we commit is we end up learning something without knowing what exactly it is for. I'm focusing more on letting you guys know that okay, my standard deviation is my technique or the tool which tells me how do I see how much of the variance I'm dealing with. Yeah. Everybody with me?
Yeah.
Yes, sir.
Um, Bavav, you have not spoken much, but I am assuming you're fine.
Oh, yes, sir.
Okay, good. Isha, yeah, please go ahead.
I have a question.
Uh-huh.
As SAT is like a time test, wouldn't this take a long time?
Wouldn't this take a long time? Meaning
If
finding.
if I if
Uh
I get a question like this, if I have to find the standard deviation the way you showed,
huh.
it will take like about 5 to 10 minutes, and that's a long time in the test.
Yes. So this is where you have to use some intelligence. Okay. I mean, see, now, see, that's why I was emphasizing on the interpretation part of it. Let's say now I'm giving you the example. Let's say if you get numbers like 12, 16, 35, and 18. Okay. Find out the standard deviation for this one, and your options are 0.26, 1.9, 16.4, and minus zero point 0.3. Now, you know how to calculate standard deviation. Let's say in your test, you have saved time and you have been rushing through very fast. So you have enough time. Then you will choose, okay, fine. I can calculate the standard deviation, find out the mean. My mean is what? 12, 16, 18, and 35. So it will be somewhere between 18 and 20. Let's say this is 20. I'm making a guess. Now you can see why I'm making that guess. 18 plus 12 is 30, plus 35, 65, plus 16, 81. What did I say? This by 4 is 20. I was. See, this is bigger than 12 for sure because every number is bigger than this. Now, 18 is something which is between 12 and 35, but 35 is much bigger than 12. So I said, okay, fine, 18. It could have been 18, or maybe I'll give some more bonus points, maybe 20. Here, my value comes as 20.25. Okay. So I'm making a rough calculation right now. 20 minus, now you look at all the numbers. 20 minus 12 is 8, 64. This is 4. So it is like 4 square 16. So 64 plus 16 80. Now this is 15. 15 square is 125. 15 square is 225. So 225 plus 80, almost 300. And then this is 4. 300 will divide by 5, which is 60. The square root of that. See here, if I have a number like this, a rough number, okay, I'm not doing exact calculation. If I have a number like this, square root of this will be what? 8 times 8, 64. Any number which is closer to that is what my answer would be. Now, Even if you don't want to do that much of calculation, what you observe here, there's too much of a fluctuation. You are going from 12 all the way till 35, which is three times of 12. You cannot have a minuscule value as a standard deviation because you know that there's a lot of deviation. Okay,
Mm-hmm.
you will knock off this guy. Your standard deviation cannot be negative by any means because
Mm-hmm.
you're always taking the difference and then the square of that. This guy is also out of picture. Yeah.
Yeah.
So here, when you're dealing with multiple choice questions, there are two ways to solve it. One is you just solve it with whatever best speed you can do. And if you are hard pressed for time, you will use elimination technique,
Mm-hmm.
right? So if by looking at this number, if you know that there is so much of a deviation, you will knock up this guy because my standard deviation can never be negative.
Right.
This is way too small. This is out of picture. Let's say if you had the third option as 0.56 or 0.58, that also you could have ruled out. Then you had this as an option.
Mm-hmm.
So elimination technique is what you will have to use. Again, different questions have different options given. So let's say you have to find out. Somebody says, again, this might be a very stupid question to say. Somebody say, okay, I have $1,000. I gave 20% to my friend, one friend, and 30% to my second friend. What? How much do I have? So you'll say, okay, fine. 20 plus 30 is given 50%. So half is given, remaining half is there. So 1,000 by two, half is there. This
Yeah.
this one you don't need to do any elimination technique. This is
Yeah.
straightforward.
Mm-hmm.
So when you read the question, spend 30 seconds to read the question and then make a judgment before you start doing it. There might be scenarios where you don't really have to solve the problem. You just have to make a judgment based on the options that you're given. So that is where my most boring technique will come handy. Read the questions, come to a conclusion before you start doing it.
Yeah.
Not every sum is wanting you to do calculation. They are trying to use our presence of mind also at that point in time. Yeah.
Yeah.
So try that. That might help.
Got it. Thank you.
Read, analyze, decide. You have to be sure how you are going to go about any question, okay? And then you start doing it. Because if you start doing it and then halfway through you realize that okay, I chose the wrong path, there's no looking back. That's the problem. Yeah.
Yes.
Okay. All right. Everybody with me so far? Any doubt, question, worry, tension?
Oh, sir.
No? Okay, that's good. All right. So this is one thing. Isha, anything else that you wanted me to cover as part of standard deviation?
No.
Summary in two lines about what we have learned so far. First thing is, by looking at the numbers, if the numbers are fluctuating too much, if there's so much difference, you will interpret that okay, there's going to be standard deviation value is going to be higher. And then the calculation method we talked about, I'll upload that video. You guys can take a look at it, watch it offline, in case you miss something. But in exam, you have to always use either solve or eliminate. They are the two techniques: either solve or eliminate. One of the two will work. Now, the next one that we wanted to talk about was when you talk about linear equation, right? I think we talked about linear equation in one of the class. When we say linear, that has two parts to it: line and something, some blabbering. Okay, AR, AR, right? So I am not a big fan of AR, so I'll probably skip that. Line is what is of interest for me. So whenever somebody talks about a linear equation, what it means is an equation or a function that draws a line, and each and every point on that line will satisfy that condition. What does it mean? Let's say y equals to 2x plus 4. Okay. If this is my linear equation, Other thing that I have told before, I'll just repeat myself. If you're talking about linear equation, any variable, be it y or x, the maximum power will be 1. It cannot have power more than 1, because the time you have a power more than 1, this is not a linear equation. This becomes a parabola or a quadratic equation or any other form of equation, but not a linear equation. In simple terms, if the power is more than 1, it will not plot a straight line. It will plot something like this, maybe. Yeah. Now, so when you're looking at a linear equation, let's say I'm giving one example, y equal to, let's say, 2x plus 3. Let's say. Now, how do we use this linear equation to plot a line? I told you guys that okay, this is a linear equation. Okay, this will plot a line, but why would you trust me? You will do it yourself. This is my coordinate plane, 0, 1, 2, 3, 4, whatever. Let's see what is the value. And I said, when I have a linear equation, meaning each and every point on that linear line will satisfy this condition. That's why it is for that one. Now let's say if I put x equals to 0, what will be my corresponding value of y? This is like a function, right? Y, value of y dependent on value of x. So anyways, let's look at equation as an equation for now. Y equal to x equals to 0, y equals to, it'll be 2 into 0 plus 3. So y will be equal to 3. When my, let's say when x, value of x is 1, what is my corresponding value of y? 2 plus 3, 5. Y will be 2 into 1 plus 3, 5. So I got 2 points, 0, 3, and second point is 1 and 5. I will use that x equals to 0 and 3. Let's say 1, 2, 3, 4, 5. This is my y-axis, this is my x-axis. Okay. 0 and 3. 0 and 3 will be somewhere here. This is my 1 point. 1 and 5. When x is 1, y is 5. This is the second point. Join these two. This is your linear equation. This is a line. Now, if you pick any point here, that also will follow this method. It cannot change. Okay. Now, this is a linear equation. But linear equation, when you talk about, it comes in two forms. One is called y-intercept form, and second is called standard form. So we'll only talk about y-intercept form for today, because that's something that came as a request for the class today. So that's what we are covering now. Y-intercept form is y. This is called y equals to mx plus t. Now here, if you compare that with the equation that we were looking at just now, 2x plus 3, compare these two guys. See, this 2 is nothing but a replacement for m, and this 3 is nothing but replacement for c. What is m in the y-intercept form? M is called the slope. M is the slope. Or it's not called y-intercept form, it is called slope-intercept form, correct? I was making a wrong statement. Slope-intercept form. This m is called the slope, and this c is called the intercept. Yeah? Are you guys with me so far?
Yes, sir.
Okay. Simple thing. Only remember this, y equal to mx plus c. This is my slope intercept form, and this, see here, the power of all the variables is 1. So this is a linear equation. This is a linear. It's going to plot a line. If you read this statement, it's called y equal to mx plus c. M is nothing but the slope. What is the slope? This or this or this. See how inclined this line is, which way the line is going, right? This tells the slope. Okay. Is it a line which is flat like this? Is it a line like this? Is it like this? This is nothing but the slope. So this m helps you decide that, which is called the slope. Okay. Now, what is c? C is the intercept. Is intercept on y-axis. Where does it cut the y-axis? That's what is c. Meaning, If you put x, see where will a line cut y-axis? Where the value of x is 0. On this y-axis, any point you pick, the value of x coordinate will be 0. Yeah. Likewise, if you pick any point on this line, which is the x-axis in the coordinate plane, the value of y will be 0. So in this equation, if you see, m represents the intercept, meaning line is like this, or line is vertical, or line is horizontal, or whatever it is. And then c tells you the intercept, meaning the point where it cuts the y-axis or where it meets the y-axis. Okay. Are you guys with me so far?
Yes.
Okay. Now, any line. What did I do just few minutes ago? I said y equal to 2x plus 3. I was just drawing this line. What did I do? I put different values for x. I put x equals to 0, let's say, and found the corresponding value of y. I could have picked up value of y as 0 and then found out corresponding value of x. That's what gives me 2 points. Here, for the sake of simplicity, what I'm doing is I'm finding 2 points and joining them. That's what becomes my line. Based on whatever equation I had, I'm finding 2 points and joining them to make a line. So essentially, I have 2 points. Okay. Now, if I'm not interested in knowing where it cuts the y-axis, okay, meaning I will take this part. I'll probably want to forget about this part for now. Or I'm just thinking, shall I say it that way, or I can put it differently? Okay, fine. Okay, forget about the intercept part. I have 2 points. Here I have x1, x1, y1. And here this is my second point, x2, y2. Okay. If I have to find out how inclined this is, what is the slope of this line? What we have to do is, what is the slope of line? Meaning, how is this line performing against the x and y axis? Let's say if the value of y, if both the value of y is 0, where will it be? If value of y is 0 for both the points, meaning it is lying on the x-axis, correct? Do you agree? Because x-axis is something where the value of all the y's will be 0. Similarly, if the value of x is 0, meaning where it will be, both the points will be like this. This will be my line. This will be my line. So, how the value of y is changing against x, that's what gives you the slope. That's what is meant by the slope here. How for every change of y, what is the corresponding change of value in x or vice versa? That gives you the slope. Meaning, look at this like a right angle triangle. Okay. See, look at this. If you join these 2 points, extend it. Okay. When you look at the graph paper, you will find that let me do this way. I don't want to extend this class for you guys. It's already been a little more than an hour. But for now, I'll just give you guys one clue and then we'll prove this in the next class. Okay. I have 2 points and I join them to make a line. If I have to find out the slope, my slope will be how y is changing for every change in x. Okay. How y is changing. Look at this one. Okay. This table. When you look at this video after the class, I'm saying how my y is changing gives me this, how my y is changing against every change in x gives me the slope. Okay. I'll give you guys a visual representation in a more mathematical form in the next class. I'll explain that. I'm not trying to push for it and rush for saying that, okay, we did, and then we end up forgetting it. Okay. Right now, I'm just giving you guys a clue that my slope is a function of how my y is changing for every change in x. Okay, and that is how my slope gets derived. In future, if you have to do it mathematically, you can say that, okay, my slope is for how my y is changing for every change of x. Okay, that is what is a slope, and I will explain that in a more practical way in the next class, and then probably we'll see if we have any doubt about it. But for some of you who are trying to solve this, if you have a line where there are multiple points, you can choose any 2 points because every point has to follow that pattern. Okay, follow the same formula for the linear equation. And any 2 point that you pick up, be it the first point or the last point, or be it any point in the middle, as long as those points on the line, that will meet this criteria. Okay, the difference of y coordinates divided by difference of x coordinate, that's what gives you the slope. I'm not sure if I confused you guys because I was trying to finish this topic, but yeah, Isha, I was not looking at the screen, so I see you have raised your hand.
No, it was long time ago.
Okay, so summary of this is linear equation. As we all know, linear equation is something which represents a line, and any and every line, any and every point on that line will meet the criteria for the linear equation. Or meaning, whatever we say, y equal to pi x plus 7 or whatever is the equation, every value of x and y will satisfy that. That is how it's part of the linear equation. Now, since we're talking about the slope intercept form, we talked about what is the slope and what is the intercept. Intercept meaning where the line meets the y-axis, and the slope is nothing but the inclination of the line, how the line is aligned to x and y-axis. That's what is the slope. Or in other terms, we can say how is the value of y changing for every change of x value. So that's what is my slope. We will look at some practical examples in the next class tomorrow, and then we'll make sure that our understanding is correct or there's something to be explained for this. Yeah, are you guys with me? Okay, so I'll upload the video sometime in the later in the day, and then you guys can uh, watch it, make sure that if there's any doubt that gets clarified, and if after watching the video you have more doubts, I'm the right person whom you can challenge and get clarified. Yeah.
Yeah.
All right, take care, and meet you guys tomorrow.
Thank you.
Yeah, all right, I hope it was good for everybody. You
What
should-
time is it tomorrow?
Yes, sir.
yeah, all right, yeah, bye bye, take care.